Modern enterprise networks rely on continuous, programmatic access to IP address management, or IPAM data, to fuel DevOps pipelines and multi-cloud provisioning tools. In traditional architectures, high-volume automated requests take a direct path to the core management database. When hundreds of simultaneous REST API, or representational state transfer, calls hit the core IP control executive at once, it creates a severe processing bottleneck. Routing external automation directly to the core database also exposes the foundational network infrastructure to non-administrative users and third-party tools. This configuration violates the principle of least privilege. Providing broad database access to external scripts introduces pathways for external reconnaissance and credential harvesting. Adding more compute power to the core server does not solve this issue. Scaling DDI automation requires a structural buffer that explicitly separates automation traffic from core management functions. This diagram maps the architecture of the Sapphire Cloud Automation Appliance, or CAA. The CAA functions as a dedicated API gateway designed to sit between external requests and the core database. Instead of routing to the IP control executive, traffic from multi-cloud environments and orchestration tools hits the CAA first. Offloading these requests protects the primary database from traffic spikes and unauthorized access attempts. The central black arrow illustrates the IPAM synchronization pathway. The CAA only communicates with the executive server when a verified, necessary data exchange is required. Beyond acting as a gateway, the appliance operates as a flexible automation engine, orchestrating complex cloud IP assignments and managing subnet deployments. Deploying the CAA shifts the DDI infrastructure from a fragile, monolithic structure into a resilient, scalable microservice architecture. Network administrators often need to allow non-daily end users to perform specific IPAM tasks without granting them full access to the web user interface. This is the minimalist login interface for a custom self-service portal built on the CAA to enforce zero-trust principles. The portal is strictly scoped. It requires only a username and password to authenticate, stripping away extraneous fields to prevent an accidental full database dump. A DevOps engineer can use this portal to execute a narrow query, such as searching for an available IP address type using a wildcarded hostname. When the user hits Submit, the front-end portal generates a targeted HTTP post request containing only their specific input payload. These custom interfaces democratize routine DDI tasks for DevOps teams, while inherently mitigating the risk of privilege escalation. Behind the portal, the CAA embeds Node-RED. Node-RED is a programming tool that replaces rigid custom scripts with visual, drag-and-drop logical pipelines. This interface displays the back-end workflow. The HTTP post request enters the logic chain here. The starting node passes the JSON data payload, a standard format for transporting data, forward. It flows into the IPC login node, which authenticates the user's credentials against the IP control backend. This authentication layer fully supports modern OAuth 2 providers, allowing seamless integration with existing enterprise identity management systems. Visual orchestration makes complex multi-step API sequences accessible, extensible, and fully auditable without requiring engineers to write raw code. The workflow actively parses and transforms JSON payloads mid-flight to ensure data integrity before it reaches the core. Returning to the Node-RED canvas, we see how engineers string multiple APIs together. Once the backend returns a result, subsequent nodes parse it, stripping out sensitive administrative data. Only a sanitized, formatted JSON response passes to the final node, returning exactly what was requested. Looking at the left side tool palette, the system provides native tools for input validation and stability. If a user submits a malformed query, a catch node intercepts the error, preventing a system crash or unintended data dump. Native data transformation and error handling ensure that self-service automation remains robust, even when subjected to unpredictable user behavior. Zooming out, decoupling the automation interface from the core database ensures adequate DDI capacity during high-load operations. This consolidated pathway maintains system availability by acting as a shock absorber. It prevents localized multi-cloud traffic spikes from taking down critical core services. This architecture directly aligns with NIST framework requirements, specifically the mandate to establish a baseline configuration of least functionality. NIST, or the National Institute of Standards and Technology, provides cybersecurity guidelines for enterprise infrastructure. Deploying purpose-built appliances like the CAA directly addresses defense evasion and credential access threats by severely limiting the external attack surface. Effective DDI governance requires separating the execution of daily programmatic tasks from the core management plane. The Sapphire CAA bridges the functional gap between traditional networking and modern DevOps by providing a secure layer for automated IP allocation. Combining a dedicated API gateway with visual Node-RED workflows drastically reduces the development cycle required for custom enterprise automation. The CAA empowers network teams to securely distribute IPAM capabilities across the enterprise, ensuring agility without compromising the core infrastructure.